In today's video, we're going to look at the most important topic when it comes to studying monopolies. In fact, you could argue that this is the only really important part of studying monopolies, is understanding if you are a monopolist, what does the idea of marginal revenue mean to you? Now, as we know, marginal revenue means additional revenue. How much additional revenue is coming in when we choose to sell one more unit? For a monopoly, if we can understand what this idea of marginal revenue means and what it means for different situations, such as in pure competition, we're going to be fine. And we can understand just about everything there is to know about monopolies. So make sure you really pay attention and understand everything we're about to talk about. So again, marginal revenue just means the additional revenue coming in for each additional unit we decide to produce and sell. And the rule, whether you are pure competition, oligopoly, monopolistic competition, or monopoly, is to keep selling units as long as the additional money coming in is greater than or equal to the additional cost of producing it. And then you stop. You don't want to ever keep producing so long that you're producing units where the additional cost of producing them is higher than the additional amount of money is bringing in from selling them, right? That would not be a smart decision. So let's think about, what does the idea of marginal revenue mean to a purely competitive business versus a monopolist? So in pure competition, we call those firms price takers because we assume that there are a lot of small firms and they're all producing exactly the same thing. And we're assuming that each of those firms are so small that they can keep producing and sell as many units as they want to at that market price. They're so small that they could try to flood the market by producing a lot in order to push the price down, but they just can't. Each firm is too small to have any effect on the price in the entire market. So from the viewpoint of each of these little firms, for each additional unit they sell, the additional revenue they bring in is just the same thing as the market price. MR, marginal revenue, is just the market price, and it's constant. They can sell the first, the second, the 10th, or the 50th, or the 100th unit, and always, for each of those units, bring in whatever that market price is when they sell it. So their only decision is when to stop. Since we know that for all businesses at some point the additional cost is going to be increasing and increasing and increasing, at what point do they stop? When the last unit they produce, the additional revenue, the price, is equal to the additional cost of producing that one, you say, okay, everybody, let's call it off. Let's stop for the day. Because we know if marginal cost is going up, if we produce one more, the additional cost is probably going to be more than the price we can sell it for. And so we would lose money on that unit. So that's when we stop, when the price equals marginal cost. Now, if you're a monopoly, you are a price maker. You're the only supplier in the market. So there's not a market price. You decide the price, and by deciding the price, you're going to also be deciding how many units people want to buy from you, right? The law of demand is not repealed just because you're a monopoly. So if you set a higher price, you know you're going to sell less. But if you want to sell more, the only way you can sell more is to lower your price. And we're going to assume, to keep things simpler, that if you want to sell more, you have to lower your price for all the units you're selling. So to think about it this way, maybe today you're selling 100 units at $100 a piece. That's how many people want to buy when you charge $100 a piece. So tomorrow, if you want to sell 101 units, you're going to have to lower your price, maybe to $95 or something like that, okay? Now, there are a lot of complicated ways that monopolies can price things, and we're not going to get into those right now. We'll discuss those a little bit in another video. And those more complicated ways that are theoretically possible, and we see them do this in real life, are called price discrimination. Price discrimination just means that you charge some people higher prices and some people lower prices. You might do this by giving some kinds of people a discount, like a senior discount or a student discount. But let's just assume that these monopolies we're talking about today are single price monopolies. Single price monopolies charge everybody the same price. There's just one price that they use. So assuming the monopoly sells to everyone for the same price We're not going to call it a market price. We're going to call it a monopoly price. Let's investigate the idea of marginal revenue from the perspective of a monopolist. So to get us started, let's look at a simple demand function. Suppose we had a demand curve that could be represented as 10 minus Q. We're going to graph it, and then we're going to calculate the total revenue and the marginal revenue if you are a monopolist choosing the price that you're selling for. So if this demand curve looks like 10 minus Q, then we know the y-intercept is 10. So again, we're always putting price on the y-axis and quantity down here on the x-axis. We're just graphing the demand curve. So if the price was 10, they would sell 0 units. And if the price was 9, they could sell 1, etc. We see the slope here is minus 1Q. So minus 1 is the slope. So we go down 1 over 1. And what this slope tells us is every time the business wants to go over 1 to sell 1 more unit, they have to lower their price by 1. Okay, let's just connect those with a straight line. And there's the demand for this monopolist. Now again, this could be 10 million units or 10,000 gallons or something like that. We're just keeping it simple so that we can get this idea of marginal revenue in our heads. So let's fill out this little table here of quantity, price, total revenue. Okay, so we see when the quantity is 0, the price is 10. The total revenue would be how much? 0 times 10 is $0 in total revenue. What about if they sold 1 unit? Well, they can sell 1 unit if they lowered their price to $9. So $9. How much is their total revenue? 1 times 9. $9 in total revenue, right? All right, and because this is a simple relationship, we know that every time they want to sell another unit, they want to lower their price by 1. So we have 8, 7, 6, 5, 4, 3, 2, and 1, and 0. If we give these things away for $0, we could give away 10 of them. That would be the quantity demanded. And we're just going to multiply the price times the quantity here. 2 times 8 would be $16 in total revenue. 3 times 7, $21 in total revenue. 24, 25, 24, 21, 16, 9, and $0 in total revenue. Now look at this interesting pattern that we're seeing here with total revenue. Total revenue starts at 0, goes up, and it reaches a maximum, and then it goes back down to 0. And if you recall studying elasticity, the maximum total revenue always occurs halfway down a linear demand curve. In this case, at a price of $5 and a quantity of 5 units. Now also, when you're studying elasticity, we know that that is the point where the price elasticity of demand is exactly equal to 1 or minus 1. And up here in the top part of a straight line demand curve, demand is elastic, and down here, inelastic. And this is just reviewing one more time that if you're at that place where you have a price elasticity of demand of 1 and you've maximized your total revenue right there, if you continue increasing your price, your total revenue goes down, or if you lower your price, your total revenue will go down from that maximum. Okay, now let's look at marginal revenue here. Marginal revenue, just like any marginal thing, doesn't really make sense when we're just starting, because marginal revenue is how much additional revenue do we get when we sell an additional unit. But when we sell that first unit, our total revenue goes up by $9. So our marginal revenue is $9. When we sell the second unit, our total revenue goes up from 9 to 16, so our marginal revenue is 7. Okay, you think about what the marginal revenues are going to be for the remainder of the table here. It's just how much is the total revenue going up. So 16 to 21 is 5, 21 to 24 is 3, 24 to 25 is 1. Now notice that when we sell the sixth unit here, our total revenue goes down, and so it goes down 1, so it's minus 1, and then minus 3, minus 5. You see a pattern emerging here, right? Minus 7, minus 9. So what this is showing us is the marginal revenue. How much additional revenue do we bring in when we want to sell one more unit? Now, so far, we're not looking at marginal cost. So we could not say for this monopoly how many units they would want to produce. We're just focusing on the marginal revenue part. And what are we seeing here? Here's the interesting pattern that we want you to notice. Notice that every time we go down one row in this table, we're lowering our price by 1, right? 10 to 9, 9 to 8, 8 to 7, 7 to 6, 6 to 5. And what that's saying is every time we sell another unit, our price goes down by 1. But what's happening to marginal revenue every time we sell another unit? Well, it's going from 9 to 7, 7 to 5, 5 to 3, 3 to 1, 1 to minus 1. So each time we sell another unit, our price is dropping by 1. That's just the graph of the demand curve. But what's happening to the marginal revenue every time we sell one more unit? Right, marginal revenue is dropping $2. So for every $1 we're cutting the price, our additional revenue is being cut by $2, or exactly twice as much. So when we graph marginal revenue, we use this idea that the slope of this demand curve here, that slope is minus 1. But here, when we look at the marginal revenue, we see that the slope is minus 2 each time. We go over 1, right? We're increasing the quantity by 1. The slope is minus 2 because our marginal revenue is going down twice as fast. So here is how we graph marginal revenue. And you're going to notice that what we do here when we're graphing it is not exactly what we're seeing in the table. But let me tell you, and we're going to show this in just a minute, the way we're graphing it is actually more correct than what we're doing in the table. And it's simpler. So if you can do something that's more correct than it is in the table, and it's simpler, let's do it that way. So here is the simple trick that we want you to do to graph this. It makes the analysis so easy. If you're going to graph marginal revenue, and graphing marginal revenue is a whole lot easier than just making a table like this. When we graph marginal revenue, we want to start our marginal revenue curve. I'm going to draw it in this kind of purple color here. We want to start at the same place we start our demand curve up here, at the y-intercept of 10. And what we want to do with our marginal revenue curve is every time our quantity increases by 1, we want to focus on that fact that the slope is minus 2. So we're going to go over 1, down 2, 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 etc. Marginal revenue. Now, right, compared to what we have here in the table, we didn't graph exactly the same points. And I know this is a little confusing, but just starting the line at the same place and going over 1, down 2, or just making it have twice the slope, I promise, it's actually a little more correct than what we're doing here, and it's a whole lot easier. Here's the lesson we want you to learn. We're going to look at this several more times in several more contexts, but here is the lesson we want you to learn. That if your demand is a straight line, then your marginal revenue is also a straight line that looks just like it, but it has twice the slope. Okay? So marginal revenue has twice the slope of demand. Here's the easy way to draw a line that has twice the slope of another line. You see how the demand line intersects the x-axis here at 10? Just draw a line starting at the same place, up here, the y-intercept, and to make it go twice as steep, make it intersect the x-axis, the quantity axis down here, twice as fast. So it intersects the x-axis at 5 instead of 10. Okay? We're taking the demand line, and where it hits the x-axis, and we're cutting that in half. And that's where our marginal revenue line is going to hit. Okay? All right, now let's look at this in a different example with a different demand curve. This is something that we can generalize. Okay, so here's a more, complicated demand curve, I guess. Price equals 102 minus 2Q. So what we're going to see here is that if we want to sell 0 units, we could charge the y-intercept price, 102. But because the slope here is -2, what we're going to have to do every time we want to sell 1 more unit, we're going to have to cut our price by 2. So if we want to sell 1, charge $100. Sell 2, charge $98 each. If we want to sell 3, 96, 4, 94, etc. Dot, dot, dot. We could keep on going and fill out this entire table, going all the way down to a price of 0 if we wanted to. Now let's calculate the total revenue for each of these combinations. Well, the total revenue, 0 times 102, will be $0 in total revenue. 1 times 100, 2 times 98 is $196. 3 times 96, $288. 4 times 94 is $376. 5 times 92 is $460. 6 times 90, $540, and so on. Okay, please, I'm begging you guys, please pause the video for just a second and calculate the marginal revenue. And then I want you to notice what is the pattern you're seeing in the marginal revenue. Please pause the video now for just 20 seconds and see what the marginal revenues are, and then notice the pattern, and then play the video again. Okay, so here is what you should have for your marginal revenues. Now remember, what are we doing here with the price? Well, the quantity in the price columns here are just the demand curve. And the marginal revenue is asking how much additional revenue do we get when we sell each additional unit. And notice that each time we want to sell 1 more unit, we have to lower the price by 2, 100 to 98, 98 to 96, 96 to 94, but the additional revenue we're actually bringing in when we sell those additional units are going down by 4 each time. Exactly twice as fast as we're decreasing the price. So if we go over here and we want to graph the demand, I'm sorry this is so small, but if we want to graph the demand and the marginal revenue, and this is what the demand curve is going to look like right here. The y-intercept is up here at 102, and then since it goes down at a slope of -2, the x-intercept down here is going to be at a quantity of 51. So quantity on the x-axis, price up here on the y-axis, as always with demand curves. What is the marginal revenue curve going to look like? Let's graph that in red. Again, we could graph all those numbers and it would be very complicated. Imagine you are a monopoly and you are the only firm in the market and you were producing millions of units. You don't really want to calculate this for every number of units and then graph all those points. As long as you're convinced that your demand is a straight line or pretty close to being a straight line, then your marginal revenue is going to start the same place as your demand curve and go down twice as steep. So if our demand line down here is intersecting the x-axis at 51, where would our marginal revenue have to intersect if it's going to hit the x-axis or the quantity axis halfway down, right? Twice as fast. Well, it would be 25.5, right? 51 divided by 2, 25.5. So it's going to hit right down around there. So let's just connect those 2 dots. All right, so just to zoom in here, we see that the marginal revenue, the red curve, intersects the same place on the price axis, and down here that would be at about 25.5, whereas the demand curve intersects at about 51. So this would be marginal revenue. So if we ever need a quick way to figure out what's our marginal revenue, it's a lot quicker to look at a graph instead of calculating a huge table like this. Okay? So that's the general principle. Take your demand curve, whatever it looks like. As long as your demand is a straight line, marginal revenue is twice as steep, and also a straight line. So just figure out halfway on the quantity axis, Draw a straight line. Lesson over. Except, well, now let's convince ourselves of this just a little bit more in a couple of other ways, and then let me show you real quickly how to use this information. So here's the overall lesson in big bold letters. If you're a monopoly, if demand is a straight line, then for a monopolist, marginal revenue is also a straight line. It's the same, but it has exactly twice the slope. So reason one, we saw it. So just believe your own eyes, believe your calculations, and believe me that this is always going to be true if demand is a straight line. Remember, that's the qualification here. So remember when we calculated marginal revenue by hand for that first example and the second example, for every dollar we have to cut the price, marginal revenue is dropping by twice as much, $2 for every dollar we're cutting the price. Reason two, let me show you this using calculus. Now, I'm not going to put calculus on the test, and in most principles of micro classes, you wouldn't use calculus, but this is just the clearest way to see it. And most of you have probably had calculus, and so let's just, in a very short, painless, hopefully, amount of time, show you why calculus is so powerful. So in a calculus class, you learn that a derivative is a slope, a change in y over a change in x. So a derivative is a slope or a rate of change. And what a derivative does in economics, and why economists use derivatives all the time, is that a derivative takes a total function, like total utility, or total cost, or total product, or total revenue. And when you take a derivative of that function, you get marginal utility, marginal cost, marginal product, or marginal revenue. So again, I'm not going to put any calculus on my test for Introductory Micro, but this is just the easiest way to show this. Let me show you real quickly. And this is actually fun. Now you get to know why you had to have calculus. So let's suppose we had that demand function P equals 102 minus 2Q. Then, what's total revenue? Well, remember that total revenue is just price times quantity. So if we wanted to make a total revenue function, here's what we do. We take the fact that this is price. Price is 102 minus 2Q. And total revenue is price times quantity. So take this 102 minus 2Q. So 102 minus 2Q. That's price, remember, since P equals that. Multiply that times quantity. And all we have here is price times quantity. And this will tell us, for any quantity we produce, what's our total revenue going to be as a monopolist? Let's just multiply this out. 102 minus 2Q times Q, we multiply through by the Q, and so we get 102Q minus 2Q squared. That is a total revenue function. So what do we do to turn that into a marginal revenue function? We take the derivative. So remember, the derivative symbol is something like this. dy dx, right? Or d dx. This dy dx is a slope. It's telling us it's change in y over change in x. So the notation tells you that what we're doing here is we're calculating a slope, or a rate of change. But since we're not talking about x's and y's, we're doing the change in total revenue as we change quantity. So imagine that Q was an x. What's the derivative of 102x? It's just 102. Minus, what's the derivative of minus 2x squared? Or minus 2q squared in this case. You multiply by the exponent, and then you subtract 1 from that exponent. So 2 times 2 is 4. Q, subtract 1 from the exponent, 2 minus 1 is 1. And we don't have to write an exponent of 1, we can just erase that. So this is telling us that our marginal revenue function is 102 minus 4Q. Here's why this is important. You remember, the slope right here for the demand curve is minus 2. The slope of the marginal revenue is minus 4, but the y-intercept is the same. This is why, when we draw these marginal revenue lines, we're just going to give it the same exact y-intercept as the demand curve. We're just going to give it twice the slope. Take whatever the slope is, multiply it by 2. Okay? All right, just to beat this to death, suppose our demand function was 500 minus 6Q. Then total revenue is going to be, we just multiply that 500 minus 6Q times Q, and we get 500Q minus 6Q times Q, or 6Q squared. And then we take the derivative of that, and the derivative of 500Q is 500, and the derivative of minus 6Q squared, 2 times 6 is 12, Q to the first. Again, we see that minus 6 slope that's in the demand curve turns into a minus 12 slope when we look at marginal revenue. Marginal revenue has twice the slope. Okay, I hope you get that now, right? Now we can take this one last step further and we can say, look, this has got to be true for any line. Even if we just say, well, whatever the y-intercept is A and whatever the slope is B, we can do exactly the same thing and say, well, look, then total revenue is going to be AQ minus B, whatever B is, could be any number, squared. And then when you take the derivative of that, that Q goes away and you just have A minus 2BQ. This is higher math we're doing right here. But the point is, it doesn't matter what the y-intercept is, it doesn't matter what the slope is. The marginal revenue is going to have a slope that's exactly twice as steep, and the y-intercept is going to be the same. We just see the general principle here. So to sum up, one last time, in pure competition, if you're one of these little firms, marginal revenue is the market price. You, as a small firm, can't affect the price. So to you, you can sell as many as you want at that market price. One small firm can sell as much as they want at the market price. You sell another unit, your additional revenue is the price you sold it for. But in a monopoly, marginal revenue drops fast, twice as steep as the demand line drops. So a monopoly can't sell more unless it actually cuts the price, since it can't take the view that I am so small that I can sell as much as I want without affecting the price. They're the only supplier, so they can't take that view. So how do we use this? So on the left we have perfect competition, on the right we have monopoly. Let's look at markets and see what would be different between these two. So on the left we have perfect competition, and perfectly competitive firms are going to look at the market price, and in this graph it looks like the market price is around $6 here, right? And the quantity in the entire market looks to be 12 units or 12,000 or 12 million, right? And so in a market, a perfectly or purely competitive market, you look at where supply and demand intersect, and that gives us the market price, and that dictates to each firm how many they're going to produce. You add all those units up that everybody produces, and then you get this market quantity down here on the x-axis. And so this is just supply and demand and equilibrium. And at that equilibrium, then we can do all those interesting things that we did earlier in the semester. We could draw triangles, and we could say, well, that's consumer surplus. And then, well, down here, this is going to be producer surplus, right? And then down here is the variable cost and the total revenue and all that kind of stuff. But what if we have a monopoly? The monopoly does not take that $6 market price as telling them what they have to do. The monopoly is interested in producing as long as the marginal revenue is bigger than or equal to the marginal cost. And then, after they stop producing, they want to see what's the highest price they can charge for those units and still sell all of them, right? So here's what changes over on the right side when we look at a monopoly. A monopoly does not have a supply curve. So we cross out this S right here. We don't say supply equals marginal cost. A monopoly doesn't have a supply curve. Now why not? Because remember what a supply curve is. A supply curve is defined as something that tells us for each market price what quantity will be supplied in the market. Well, there's not a market price if you're a monopolist, so this definition of there being a supply curve goes out the window. However, the monopoly does have marginal cost, and marginal cost is important. So we just call this line a marginal cost curve now. Well, what else is going to change? Oh, right. If we're talking about a monopoly, we have to draw this marginal revenue curve. All right, tell me, what am I going to do to draw this marginal revenue curve? we're going to start at the same place up here where the demand curve hits the price axis at 12. And then we want to draw a line that's twice as steep. All right, well, look at this demand curve. It intersects the quantity axis at 24. A line that's twice as steep is going to hit the quantity axis where? Twice as fast. Instead of at 24, it's going to hit the x-axis at 12. And then we just connect those two with a straight line. Marginal revenue. And so let's look at this little rule for monopolists again. Keep producing as long as marginal revenue is greater than or equal to marginal cost. So when we start off here, we see that the blue line, the marginal revenue, is higher. Let me just draw some dots here. Marginal revenue is higher than marginal cost. And so they want to produce that first unit, or the 1,000th unit, or the 1,000,000th unit, or whatever. And then if we go towards the second, the marginal revenue up here is higher than the marginal cost. So they want to produce it. It means more additional money's coming in than it's costing them. So that's a good thing. And then for the third unit, marginal revenue coming in looks like about $9 a piece, and the marginal cost looks to be below 4. Marginal revenue, marginal cost. Keep going as long as marginal revenue greater than or equal to marginal cost. And we keep going, and we keep going, and then we stop right here. We stop when the last unit we produced, the additional revenue coming in was equal to the additional cost of producing it. So if we do a super zoom in here, let's just kind of guesstimate what kind of number it is we're looking at. Just going to do the best we can. Let's suppose this is in thousands, and we're going to guesstimate. We don't expect you to guess the same number, but something that's reasonable, a little bit bigger than 7. So this might be 7,200, or we could just call marginal revenue 7.2 thousand units, or 7.2 million units. And it looks like the marginal cost here, where the marginal cost of the last unit and the marginal revenue of the last unit produced, looks to be just below $5. Let's just guesstimate that marginal cost and the marginal revenue of the last unit produced around $4.90. However, that $4.90 is absolutely not what the monopolist is going to charge. Well, why not? Well, here's the easiest way to tell why not. Why would a monopolist charge $4.90 when in a dog-eat-dog competitive world, they're charging $6, right? If I'm a monopolist, what monopolies do is they lower the quantity they produce so that they can raise the price above what a perfectly competitive market is going to do. So here's what the monopolist does. They look at that number of units that they stop producing at, that 7.2, and they ask the question, what is the highest price I could charge for 7.2 million units where people would want to buy 7.2 million units? And that's going to be given to us by the demand line here. So the way I remember what to do here is, for a monopolist, look where marginal revenue equals marginal cost. Then look down at the quantity axis to figure out how many to produce, and then look up at the demand curve to figure out what price to charge. So if we look up, and then we look over here at the price axis, that might be, let's call it around $8.40. This would be PM, the monopolist's price that they would charge. And it makes sense with the story and the goal of what monopolists do. So let's compare these side by side once more. In a pure competition market, the market price would be $6, and they would produce 12 units, 12 million units, say. Once a monopoly takes over this industry, their goal is going to be able to sell for a higher price, but if they're selling for a higher price, they have to sell fewer units. So this is the goal of a monopolist: figure out a way to cut the quantity so that they can raise the price. So in this case, they're going to cut the quantity from about 12, just for comparison, right over here. That would be the pure competition result. Equilibrium price of 6, equilibrium quantity of 12. the monopoly is going to cut the quantity from 12 to 7.2 and raise the price to $8.40. Now, what else could we do here? Well, again, we can answer the question, well, what would happen to the amount of producer surplus and consumer surplus, and is this going to create a deadweight loss? In this graph, the consumer surplus would go down to this little yellow triangle here. Consumer surplus is the area below the demand curve and above the price, right? So it's this whole yellow triangle. The marginal revenue line shooting through the consumer surplus doesn't affect the fact that this entire yellow triangle is consumer surplus. And the producer surplus would be down here, everything below the price they sell for and above the marginal cost curve. Right, so that would be the producer surplus. And variable costs, as always, is the area below the marginal cost curve. Can you see where the deadweight loss is going to be? It's going to be over here, this gray triangle. Why? Well, recall what a deadweight loss is it's the amount of total surplus that gets decreased because for some reason we're not producing at that place where the marginal cost equals the marginal benefit. When the monopoly raises that price and cuts the quantity, we're not producing at that equilibrium point where the marginal cost equals the marginal benefit. And so just like a tax, or just like a production quota, we're not producing at that efficient level, and that's reducing the amount of total surplus. So to make that slightly clearer here, the total surplus over here on the left, when we're producing at that market equilibrium and pure competition, would be this entire orange shape, total of consumer and producer surplus. Over here, this shape that includes the yellow, the pink, and the gray is the same exact shape, so it's exactly the same area as the total surplus on the left, but you see part of it is not going to consumer surplus or producer surplus. So that is the deadweight loss. Let's do one last example very quickly in just a couple of minutes so that you can see, once you get this idea in your head, how easy it is to do. So again, on the left, we're going to look at pure competition. We're just looking at where supply equals demand, and so we're going to be here at an equilibrium price. It looks like around $85. And an equilibrium quantity of, again, 12 or 12 million units. And so we would, again, have this huge total surplus. And we know we could break that into consumer surplus and producer surplus and all those good things. But when we're looking at monopoly, we just want to really focus on the idea of what's changing when we go to a monopoly. So here, equilibrium price, equilibrium quantity, and the orange total surplus there. For a monopoly, what are we going to do? Draw the marginal revenue curve. It's just a line that has a twice as steep slope as demand. And we don't even need to know what the function is that we're dealing with for demand. We don't need to know what the slope is. We just need to look at it and say, well, I'm just going to draw a line, and it's going to start up here at a price of 120 and a quantity of 0. And I just look down here at the quantity axis. So that demand line hits at 40. Where is the line that's twice as steep? Going to hit the quantity axis. Right down here at 20. So we draw that marginal revenue. Also, just to be really picky, what I like to do is say, well, this is not a supply curve now because we're talking about a monopolist. And a monopolist doesn't have a supply curve. They have a marginal cost curve, though. And then the monopolist is going to keep producing as long as this additional revenue coming in is greater than or equal to the marginal cost of producing. And then they're going to stop right here. And it looks like they're going to stop producing at around, and again, this is approximate. We're not trying to get an exact number, but just pick whatever looks like it's pretty close and pretty obvious. We're going to call that the monopolist quantity. So QM, monopolist quantity, would be 9 units instead of the 12 that the pure competition was going to result in producing. And the marginal cost where they stop producing is 65. But we don't care about that so much. What we care about much more is what price is the monopolist going to charge. So when you're dealing with a monopolist, again, look and see where marginal revenue equals marginal cost. Look down to find the quantity where they're going to produce, and then look up from that point at the demand curve to find what's the highest price they can charge for those units. It looks to be about $95 would be the PM, the monopolist price, compared to $85 over here, which we might call PPC, pure competition price. And make sure when you're done that you know that a monopolist is always going to raise the price compared to what a highly competitive market would do, and they're going to produce less, right? So make sure that this quantity is less than the 12 that a pure competition would do, and that the price is higher than what a purely competitive market would result in. And then we want to be able to point out that deadweight loss. We see right here, this little triangle is going to be the deadweight loss that this monopolist would create. And that is the biggest reason, the biggest argument for economists why monopolists are bad. There are some others, and we'll discuss those in the next video. But this is the biggest reason. When you are failing to produce these units between 9 and 12, you're failing to produce units of a good. Let me super zoom in here. There are units here where the additional benefit, the value to people, is higher than the additional cost of producing them. And when you fail to take into account that you could provide high benefits for low cost, you're not making society as well off as you possibly could. And that creates that deadweight loss. Now let's calculate the area of this deadweight loss, because that's pretty easy to do. This triangle here, it's a triangle 1/2 times the base. And I think about the base as being this side over here. So the base is just going to be the difference between the price, $95, and that marginal cost down there, $65. So 95 minus $65. That base right there is about 30. And then the height is the height from the base up to the highest point. And so if we go from the highest point down here to the base, we just want to know how high is that. And we can see down here on the quantity axis that what we're talking about there is the distance between the 9 units the monopoly produces and the 12 units that we would see produced in perfectly competitive industries. 1/2 times 30 times 3 equals $45. Or this could be 45 million or 45 billion, depending on how many units we're talking about here in the entire market. So that's going to end this video for today. Remember, the most important thing that we talked about over and over and over again is that marginal revenue for a monopolist, as long as the monopolist demand curve is a straight line, marginal revenue is a line that's twice as steep. And the marginal revenue is going to tell the monopolist when to stop producing. Keep producing as long as marginal revenue is greater than or equal to marginal cost. Look down at the quantity axis to see how many they should produce, and then look up to find the highest price you can charge and still sell those units. And you're going to find that up on the demand curve. As always, if you have any questions, anything that you think I could clarify here, please let me know. But this is the most important topic when you're talking about monopolies. Everything else is secondary. Of course, there are some important things, and of course, we'll talk about those in the next video. Thanks for joining me, and I hope to see you then. Good luck with all your studies, everybody. Bye-bye.